Hi, dear students. In the last week, we had certain midweek worksheet. So certain students asked me to kind of like having a review on these with the specific questions. Not all, they were just finding somewhat hard, and actually I added all those questions to guide you to do how the exam level. So in the exam, they are not seeing your lullabies. හරිද? ඒ කියන්නේ නලවිදි කියන්නේ නැහැ. කෙලින්ම අහනවනේ. So I have to give you some practice for that. So that's why I decided to add you right a good questionnaires. So by the way, today we are going to want to explain of these some of these questions, not all. The most of the questions that students requested. Now I'm going to discuss in this one as a review video. So let's go on to the video and let me just introduce it. So in the equation here, this is very simple question actually. Velocity is cms minus 1, and in terms of kind of like the dimension, we don't care whether it is like cms minus 1 or kilometers per hour or whatever, because it is the velocity. So it's going to be ld minus 1. So velocity factor is what? ld minus 1. Now here, t is in seconds, that means the time, capital T, and in the relation, so the dimensions of A, B, C are, so velocity dimension should be equals to dimension of AD, so that means LD minus 1 is equals to A times capital D, so the A will be A, dimension of A is LD minus 2. Now check for the answers. There is only one answer. Come up with 30 minus 2 for the first one. That is this. So from this one only, you can just go for the final answer even. But no problem. Let's check it. Let's check it. Now here. Now the second one. Here. So you should know one thing, only the light quantities can be added. So in the second one also, third one also tally. See, that one also tally. Let's see for this one even. The time and time. So the next one, velocity dimension should be equals to dimension of v over t, because you can just remove, and because in terms of the homogeneity, we know that if length added by another length and make it like, imagine 3 meter, 5 meter, and 8 meter. It is L. This is L. We don't call it like 2L. We just call it like L. So like that way. So you are only taking the dimension of one part of it. The V part, dimension of V will be LT minus 1 multiplied by T. So it is L. So actually these questions look very complicated, but it comes up with your IQ. See, once you find out the first answer only, sometimes you get the answer. For the rest, see, there is no other answer tallying to LT minus 2 for the first answer. So you don't actually want to solve for the B and T. B and C actually, right? There is no answer tallying to your previous answer. So this is how you are going to save your time, but this is how you just got everything. And the dimension of C, as I told you, is T. So all three are balancing here. Now in the next one, on the plane progressive wave velocity with v, displacement of the wave position, x position means a displacement. Remember that always is a displacement. Um, x, and here it is like the time t, okay, represented. So y is the position, so that means it's going to be dimension of like amplitude in 6 meters. So this part should be also meters. Y dimension is L cable. Okay, you should know one thing. You don't really want to consider about any of this. It is only you need to think about sine k v t minus x. Right. You don't even want to worry about what is v either, velocity and time. So since this one is okay, so now displacement as it is. The position means displacement. So this magnitude will also be multiple is also L. So you can just take all as L. So in terms of sign, whatever inside the sign, whatever cos, whatever tan, whatever log to base something, whatever LG, whatever LN, whatever, or e to the power something, whatever, this type of power, whatever. Whenever you find this type of constants, you should draw that all the time. The result is one here in dimensionally, one here dimensionally, one here, one, 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 and the one, and one. So K into L should be one. K L is equals to one. So dimension of K should be 1 over L. So that means L to the power minus 1. L minus 1. L minus 1 means L minus 1 be 0. The answer is D. It's a very, very simple question. As may look complicated. And here, I normally give you the note, like in the definition even, for the vernier scale, the simplest vernier scale definition is the division of 9 millimeter parts into 10 equal divisions to make it vernier scale. Forget about it. So here it is like I said, like the complicated one, division of certain scale into 10 of the main scale into n plus 1. So with regular way is n over n plus 1 x. This is how the regular way. But sometimes it is given in the opposite way even. So here the slide caliper, n divisions of the vernier scale coincide with n minus 1. So here I took n as n for the numerator. That means the main scale. Here you can take n for the vernier scale. So you should know one thing. The other one is always n minus 1. So vernier scale is 1 more. That means if you give n for the vernier scale, the main scale should be 1 minus. So if you give the n for the main scale, that means the vernier scale is 1 plus. One thing more here, if you want to find out the 1 for the main scale, that means 1 always lesser. So n minus 1, very easy, right? And MSD. See, answer is already there. See, it's not a very big rocket science over there. Very, very simple one. A vernier caliper used to measure length of cylinder, vernier divisions of scale, 9 divisions of the main scale. Now, it actually, you know, it's the least count, but no problem. So let's find out the least count. 1 millimeter, right? Over 9 millimeter over 10. So in this way, you will find it out like 0.1 millimeter, but in terms of centimeter, it should be 0.01 centimeter. Now, have a good look at it. Cannot be decimal point of 0.1 of millimeter. Vernier scale is just for what? 0.1 millimeter. So you can't measure this at all. And this can matter, but we have to think. And the third decimal place is unreachable with the scale of vernier. So definitely not. And this one is also, but most suitable, asking like the best suitable. So you know that the 10 centimeter is the benchmark for meter ruler. So anything below belongs to vernier. So the best means if the reading is very high, because why? Error. So a percentage error is always absolute error. That means the least count for many occasions. Divide by the reading, multiplied by 100%. So here, if your reading is very high, this is a constant value, you know, the percentage error keeps reducing. You should not get something with the lowest possible percentage error. So the denominator of the equation, that means the reading should be greater. When the reading is greater, your answer is absolutely final. I hope that you can understand this part. Now let's move on to the next one. Here it is like, given that y equals to a sine 2 pi over lambda c t minus x, right? Where x y meters, the figures are lengths. So no need to check the other part. So which statement is true. So have a look at it. Now c into t means you can easily find out c because it should be length equals to c t. C is equals to lt minus 1 length c. You can find it easily. Now a sine here, this whole together it is the length. Have a good look at 1 should be equals to 2 pi means a number you are not going to consider. So it is like length over lambda. So lambda dimension should be equals to 1 as well. Sorry, L as well. So when equals 1 pi, lambda should be equal to L. Okay. Now I found both the situations here. The unit of lambda is as same as for x and yeah, because x and meters. So its dimension is meters. So definitely this one is correct. Same as of, but not for a. No, a and for meters means it is definitely outside one is always equal to here. So that is also correct. So this is not. So the unit of c is the same as of 2 pi over lambda. No, we just found. And the unit of c minus is no. With this displacement, the answer already found is a. Now here, this looks very, very, very absolutely complicated. Even teachers are finding hard in this to solve. So not actually too hard, but you have to get the clear idea. So it is found that the zero of the vernier calculi is between, let's say the no zero error, there's no zero error, 5.10 centimeter. Listen to this one very carefully. 10, and it is lying between 5.15 centimeter. Okay, that is the least count. Okay, it is like 5.10. The next line is 5.15. Okay, the difference of the main scale is always what? Have a good look at when you subtract these two. 0.05, sorry, centimeter is the least count. In terms of centimeter, 0.05 centimeter is the least count. It is very understandable. Okay, you have to find it. It's not directly given like the normally like 1 millimeter, 0.5 millimeter, 0.5 millimeter is 5 centimeter. Nothing is directly given. You have to find that. Okay. After you found it, the rest of the things will be kind of easy. So it says like the vernier scale has 50 division equals to this much. Okay, let's find out the vernier scale division. Okay, now it is about to find out the vernier scale division. Now it is like 2.545 over 50 is going to be the least count of the vernier scale. Right, it's almost like 100. I will write like 245 into 10 to the power minus 2 over 50. Right. How many fives are there? 10. And how many fives are there here? So for 200, it's going to be like 40 and 5.5. Okay. No, not sorry, 49. 49. 49. It is 49 parts. 49 parts are there. Right. When you divide it by 4.9, again multiply by 10 to the power minus 2, that means 0.049 centimeter. 0.049 centimeter. Right. Now it is your time to find out the least count of the vernier. Least count. How to find out? Normally, main scale division, MSD minus VSD. So this is what the VSD. Okay. Now let me apply. It's like 0.05 centimeter minus 0.049 centimeter. This you can write it like 50. It is like as 50. 50 as a 50. That is 50 minus 49. That is 0.001 centimeter is the least count of the instrument. Right. Now it is going to be the life piece very easy after this. So the main scale should be started up with this one, and the vernier scale will give the next part. So the reading is going to be MSR main scale reading plus vernier scale reading. So the main scale reading is already found. What is the main scale reading? Main scale reading is 5.10 centimeter plus 24th line 24 multiplied by 0.001 centimeter. Right, okay. Now when you multiply here, the next decimal point, if you just get the next decimal point out of this course also, now it is like 5.10 centimeter plus 0.024 centimeter. The answer is obvious. This one, let's find it. So now it's like 5.124 centimeter. Got it? It's not a very big deal. It's not a rocket science. Very, very, very easy thing. Now this is going to be rocket science for many students. This is going to be rocket science for many students. But it is as them as very easier. And I also made a paper including these two as well as a big worksheet with the answers, right? Answers included in there. But I decided to give you like a video recording this explanation for this one. Because sometimes we might not be able to understand the paperwork itself. So here it is come up with video assistance as well. Okay. Here, how we could look at here. There are two vernier calipers with both have the 1 millimeter as the dimension and equal distance of the main scale. Okay, 1 centimeter 10 means the least count is 1 millimeter. It is given in the right way. The caliper 1 has a C1 has a 10 equal divisions corresponds to 9 main scale divisions. It is a regular vernier scale. It is a regular vernier scale. You can just read it as it is. The reading of the two calipers shown below, the measure the value in centimeters of C1 and C2 respectively. This one is really measurable in the regular way. So have a good look at 2.5, 6, 2.7, 2.8, 2.8. Main scale is 2.8 centimeter. And the other one you can see like here 7. So vernier scale reading is 0.101 centimeter multiplied by 7. So the answer is 2.8 centimeter plus 0.07 centimeter. So the answer is the reading is 2.87 centimeter. That is obvious answer. Very, very easy. Now for the next one, it is not the regular type of vernier scale. It is fairly different vernier scale. Okay. 10 equal divisions corresponds to the main 11 main scale divisions. Here normally we take like vernier scale, main scale small parts into one more in the vernier scale. But here, vernier scale is one lesser than. So that's fine. Let's try to find. Firstly, let's find the least count of the vernier. VSD 10 millimeter, sorry, 10 millimeter divided by 11. Sorry, 11 millimeter. I made a mistake. 11 mm divided by 10, that means 1.1 centimeter is the least count of the vernier scale division. Or in terms of centimeters in cm, 0.11 cm. Very bad, no? Okay. There is a trick to do here. There is a what? Trick to do this. Okay, let's firstly find out what is the value of this. It is appearing to be like the sixth line in color, aligned with, right? In line with. Sixth line is in line with. Oh, wait. Seventh line. I will take it like the sixth line. Now read the meaning in the this is undone, undoable with the regular way. Now read the main scale reading tallying to that line. It is going to be like 3.5. Now the main scale length is 3.5. Let me explain you why it is. Let me explain you why it is. This is the main scale line. Let me draw the divider. The stopping point here is 3.5 centimeter, right? Okay, remember that it is the 3.5 centimeter. Now, have a look at where the other one, that means the vernier scale, stop there. Vernier scale has like almost 6 divisions. Okay, vernier scale has some 6 divisions. Vernier scale has some 6 divisions gone from the visible color here. Now you can see another thing. The line had cut certain line over there. See, it had cut certain line over there. So the total length, if you can subtract this additional length from, sorry, up to here, the total length is here 3.5. You can cut loose. You can find out the length until to the vernier 0. There is a gap over here. There is a gap. We don't really want to worry about that gap even. I just need to actually remove what? I actually need to remove this yellow line from the blue line. Blue line length, I already know. What is the yellow line length? Yellow line length is the vernier length. What is the length length? Vernier length. Okay, what is that vernier length? How many parts? It seems like there are like about 6 parts. Okay, let me multiply 6 parts of 1.1. Remember that it is about 1.1. Okay, that means 6.6. 6.6 what? Millimeters. 6.6 millimeters in terms of centimeters, it's going to be 0.66 centimeter. Okay. Now you have the reading of the centimeter of the length here. If you subtract this part, it will show the final destination. Let me subtract now. The total length is 3.5. Reading is 3.5 centimeter minus the yellow length. Yellow length, I will write that in the yellow line given. Yellow length is 0.66 centimeter. How really good look at. Now, subtract 350, it is like 350 minus 66. Yeah. So, right. Then gone, then this will now be 10 here. 4 and 9 and 3, 8, and the decimal place is going to be placed here now. 2.84. Answer is what? It is 2.84 centimeter. That is really easy one. But if you can catch up the method, if you don't catch up the method even after this explanation, I included that in the extra paper I prepared for this week. If you don't still understand, contact me directly. I'll explain it very simply. Now, in a traveling microscope, 1 centimeter of the main scale divided into 20 equal divisions, and there are the vernier scale. I told you there is a simple way of getting the least count. What? X in the main scale divided by n number of parts in the vernier scale. This is also the principle worked in micrometer screw gauge. Let's apply. So what is the vernier scale division now? First of all, I have to find it. Okay. Now have it. 1 centimeter. 1 cm into 20. 1 into 20 means 0.5 and 0.05. 0.05 centimeter is the main scale division. Okay, this is going to be MSD. MSD. So you are going to divide main scale division to 50. 0.05 centimeter divided to 50 equal parts. Now let me just multiply 5 into 10 to the power minus 2 divided by 51 over 10. It is like 1 into 10 to the power minus 3 centimeter. Or in this case, sorry, 1 there, 0.0051 centimeter is the least count of the microscope. Or in terms of the millimeters, you can write it like 0.01 millimeter of the main scale, sorry, least count of the microscope. These are the questions that were looking kind of like challenging in the paper. Actually, these ones were really, really easy. If you find something difficult, always contact me. I have all the solutions for you. Okay, Ramai. God bless you. God bless you.